Till now in this Python for data science series, we have covered lot of amazing concepts. In our today's video, I'm going to talk on one more cool concept that is called as Python decorators. If you don't know what are the Python functions and Python object oriented programming, then I highly recommend you to watch our previous videos from our playlist. And if you already know about this concept, then there is no need to wait. Let's dive into the world of Python decorators. So what is Python decorators? A Python nested function which allows us to modify the behavior of another function without changing its code directly. If I have to tell you this in a layman terms, I will explain this concept by using the help of robots. Imagine a situation in the future where humans and robots are living with each other. Robots can do their day-to-day tasks because the future is really peaceful. Let's hope that there is going to be an alien invasions and aliens are planning to attack humans. Then we have to prepare our robots to fight these aliens. And instead of modifying each and every robot, instead of that, what we can do is that we can attach laser guns to them. So these laser guns are like decorators. To attach these laser guns, we don't have to change our robots internally. We can directly just attach these laser guns to them and they are ready to fight. Let's see this example with actual coding. There are three types of decorator: function decorator, class decorator and method decorator. Let's begin with a function decorator. What do we have in a function decorator? We have to create first one function for our basic robot. So let us create a basic robot function. Let's say that this is a basic robot. So we have created one basic robot function and this robot will return one statement. Now we are getting our output: I am a basic robot and I can't fight. Now we have to change this basic robot so our robot can fight our alien enemies. Let's see how can we create a function decorator to add this laser gun functionality to our basic robot. So I will create a decorator function as a add laser gun, and inside that I will create one more nested function as a wrapper. This is the syntax of a decorator. Now inside this function I will here write the actual functionality of my laser gun. So I will mention here that attaching laser gun. Okay, after that I will print that I have laser gun and I can fight. Isn't it amazing? So we have created our decorator function, but we have to call this inner function by using this add laser gun. So what we will do, we will simply return our that inner wrapper function outside. So this way we are able to create a decorator function. One thing that we can do is that we can also pass this basic robot function inside our decorator. So I can say here function and I will pass that same function in this one also. Whatever our function is going to return, I will print that. So it will basically print that this first line, I am a basic robot and I can't fight. After that we will attach a laser gun, and once our robot have a laser gun, it can fight. So let's see how this is going to work. So we have created a decorator, but in order to attach that decorator to our function, we have to use @ symbol and write the name of our decorator. Now this way our function is decorated with another function and we don't have to modify its internal code in order to add some additional functionality to this. When I run this code, you see what output we are getting. It is printing this function. Which function it is taking? The basic robot. It is printing I am a basic robot and I can't fight. After that it is printing attaching laser guns and I have laser gun and I can fight. So this way we create a function decorator. If you notice something, our wrapper function is accessing the function which is we are providing to actually adding laser gun, but inside our inner function we can use that parameter, and ability to do that is called as a closure. Now let's see what is a class decorator. First let's create one class. I have already created one class and its object like this one. I have created a class for manufacturing basic robot, and it is going to, when it is going to get initiated, we have to provide a name. I am providing name as a terminator to our robot, and the ability to fight, I am printing there that I am basic robot and I can't fight. So our robot, the manufacturing that we are doing from our class, we are not able to fight with this robot. Now we have to create a decorator for our class, so our robot will be able to fight our alien enemies. In order to create our custom class decorator, the way to write that is very similar to our function decorator. So we have to mention a function that modify robot, and we have to take this class as an input here. Then we will mention another class modify to fighting robot. Okay, and in that we will transfer this another, the same class that we are taking, we will transfer it, and here we will mention a fighting method. So whenever we are going to mention a method, we always have to write self there, and here I will print, I will here print the previous method of a fighting, and I will also print the current method where we are attaching laser gun, where we are attaching the laser gun. I will simply copy from here, Control C and Control V. And just like our previous function, we have to return this inner class. Now our decorator is ready, so we will apply our decorator as a modify robot. Now if we are modifying our robot, we can attach this laser gun to our robot, and our robot is going to be able to fight our enemies. Now let's see what we get as our output. As you can see, we are getting here output, I am a basic robot and I can't fight. Why we are getting none here? Let me check. The reason that we are getting none as output, because our original fight method does not return anything. If instead of writing this, if I replace this print statement with a return statement, now our fight function is returning a value, so we will not get any output as none. Let's take this same class and let's see what are the method decorator. Let's suppose that instead of applying decorator on entire class, I just want to apply that decorator on our method. How can I create that custom decorator? In order to create that decorator, I again have to create one function as a add laser gun function, and which will take method as its input. Then I will create one wrapper function which will wrap my internal code, and what I will do, I will return this wrapper function, and inside this wrapper function I will write my main code. Here I will say inside this So this wrapper right now will not act as a function, it will act as our method. So we have to mention self here in order to act as a method. If we want to print the this line inside our decorator also, then what we can do, we can call this method and we can simply call it, then it will print whatever it is going to return, it is going to print it here, right? So what I will do, I will add now main decorators functionality here as a attaching laser gun, and its main functionality that I have a laser gun and I can fight. To apply this method decorator, we have to go inside our class and apply that decorator on the desired method. In this fight method, we want to apply this add laser gun decorator, that we will do add laser gun. Let's see what we get as our output. Now we are getting our output as attaching laser gun, I have laser gun and I can fight. But I wonder why it did not print I am basic robot and I can't fight. This happened because our method is returning that value and we have to store that return value and then print it, or I can directly print this, then it will also work. Rather than storing, I will directly print. Now I will get it as my output. I am a basic robot and I can't fight. But once it goes inside the decorator, attaching laser gun and I have laser gun and I can fight. Let's say that the war is over and fortunately we humans win with the help of our laser guns, and we don't want our robots to carry these laser guns with them anymore, because we don't know when these robots can kill us humans also, right? So we have to be secure and we have to take their laser guns from them. So we can simply remove this decorator, and when we execute this, then again our robot will become a basic robot and it will be not able to fight anymore. And if let's suppose something else again happen, we will again attach this decorator and our robot will have that additional functionality with just one line of code. Isn't this powerful tool to use in a coding? So if we talk about one of the real world use case scenarios of the decorators, let's suppose that I have this function and I want to do the logging and debugging for this function when I am going to create it, okay? And once my code is going to go into production, I no longer need that maybe logging and debugging there, right? So for that purpose, I want to add one decorator for this. So I have pre-written this code. So here what I am doing, I am simply using the same method here, and this decorator will record the date and time when my function is going to get called. It will record its history whenever it is going to get called. Let's see how this is going to work. And I think I have to import the date time function. So I will say import. I will import the date time. I will apply this decorator on our function. See, if you see this right now, our which function is getting called, function basic robot called at, it is printing the date and the time of that activity. You may be wondering that what if we have applied more than one decorator on a same function, then what will be the result? In order to save your time, I have already written this code and I am using two decorators on a same function. Okay, so my function 1 is a number 1 function which is going to return value 10, and the number 2 function is going to return value 10 again, right? Now what is going to happen on the first function, I am applying the decorator as, if you see, I have created two decorators. Decorator 1 will take the square of that decorator and decorator 2 will multiply the value number 2. When I am going to apply this decorator in this sequence, then what will happen? Which decorator will apply the value on the first? Now if I run this code, let's see what output I get. So first what is happening is that decorator 2 first gets executed, after that decorator 1 gets executed. That means if my value is 10, if you take this example, if my value is 10, then first it will go inside the closest decorator, which is decorator 2, and it is going to get multiplied by 2, which will be 20. 20 into 20, it becomes 400. And the same goes for our function number 2. So in that it returns the number 10, which gets inside this function first, and it gets multiplied. So 10 into 10 becomes 100, then it is get multiplied by 2, so we get 200 as our output. So it is called as nothing but a chain of decorators, and the closest decorator gets applied first, then the second decorator gets applied. I hope I was able to explain this decorators concept to you in a little bit fun way with the help of example of robots and aliens. And still, if you have any of the doubts, feel free to reach out to me at LinkedIn. I will be happy to help you. If you have any doubts, you can ask me in the comment box below. If you want the code that I have written, then I will provide my GitHub link inside the description box below, so you can go check it out. So that's it for custom decorators. So I hope you enjoyed our today's video and you got to learn something new today. And if you want to get amazing content like this one, then please subscribe to our channel, hit that like button and share this video with your friends. Thanks for watching. Let's see the bright side together.